The Indian Association of Structural Engineers, also known as IS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IS-Struct-E is registered under the Societies Registration Act 21 of 1860. IS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IS-Struct-E has collaboration with various international professional like-minded associations and institutions. IS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements, and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IS-Struct-E's activities are widely appreciated and known for quality technical contents. IS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IS-Struct-E's publications are becoming popular with time. IS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IA Struct E is available on its website www.iastruct.co.in.
Hello.
Yes, sir. Yes, sir. Please start.
Okay, dear friends, welcome to the participants to attend this webinar. Today's topic is essentials of effective waterproofing. The speaker is Engineer K.P. Abraham. On behalf of association, I thank Engineer Abraham to spare his valuable time and we'll talk on the topic essentials of effective waterproofing. About the speaker, Engineer K.P. Abraham, former Chief Engineer CPOD, graduated in civil engineering from Kerala University and thereafter did his MTech from IIT Kanpur in structural engineering. He also holds postgraduate diploma in management. After working for 2 years in Tata Steel, he joined CPWD in 1982. I know him personally, and then he has been associated with very important projects in different parts of the country and handled numerous projects, planning, design, construction, pertaining to hospitals, airports, international sports, office complex, housing, monuments, tourism, roads and bridges. He handled major and complex projects across the country. Some of the recent projects handled by him are Signature Bridge over River Jamuna, then CAG headquarters building in Delhi, and the last one, Supreme Court Annexi building. He is a member of various committees and particularly VAS and ICI. He was chairman of ICI Technical Committee that brought out the handbook on waterproofing of concrete structures. Regarding the topic, the brief of the topic is, as we know, that any built environment must provide healthy and hygienic space and safeguard occupants from illness or injury. Hence, the building shall be protected from water ingress in any form, as the ingress mostly affects the health and hygiene of the occupants, and in addition to that, it affects the durability of the structure. Many new technologies were introduced in the last few years, making available a host of new products and application systems for waterproofing. We expect that building and structures are effectively waterproof, but there are still many instantaneous problems, particularly leaking the basements, retaining walls, balconies, toilets, etc. His presentation essentially would consider for making waterproofing effective. For ages, asphalt or coal tar has been the prime material for waterproofing of structures Then brick bats cover has been the conventional system for waterproofing of terrace. With progress made in polymers technology, there's a quantum jump in the waterproofing technology with wide range of material and application to select from. The presentation also gives an overview of the present day waterproofing technology to enable us to select one appropriate waterproofing system. Mr. Abraham would also discuss the building with two basements recently constructed in the annexure of Supreme Court building, New Delhi. Please listen and then put your questions, and then in the end of his talk, you will be you're welcome to. I mean, he will reply to your questions. So, Abraham ji, I hand over to you. Mr. Abraham?
Hope my screen is visible and
Yes,
my
sir.
voice is clear.
Yes, sir.
Yes.
Continue now.
Yes, please continue.
Good evening. Let me welcome all of the participants to this webinar presentation. Before starting, let me express my thanks to IS30, especially to Dhawan Sahab, for inviting me to make this technical presentation. Today's my presentation will be on some of the essential factors or parameters to be considered to make the waterproofing successful. As you all know, waterproofing is one of the neglected elements in the construction industry. Its cost elements are practically negligible in the overall cost of a project. It is in the range of, say, around 2% of the overall building project cost. With the result, all the participants of the project take waterproofing very lightly, be it the owner, be it the contractor, be it the consultant, be it the subcontractor, they all take it lightly. And the owner essentially depends on that guarantee given by the contractor or the subcontractor. And this guarantee is okay as long as there is no major defect or any major leakage. Once there is a leakage, once there is a failure, the blame game starts. The contractor may not respond. The subcontractor will not be available. He will run away. And the repair or the rehabilitation or repair of the building is going to be time-consuming, costly, and moreover, it will create a lot of inconvenience to occupants of the building. This is the criticality of the waterproofing. Cost-wise, it may not be a major element, but inconvenience-wise, subsequent inconvenience-wise, it is one of the major factors. This criticality has to be addressed. And I will be presenting some of the factors, some of the parameters, some of the steps to be taken to make the waterproofing effective, so that you can have a comparatively better service life of the building without any major defect or leakage. With that preface, let me come to my presentation. We'll start with the need for waterproofing. You know, entry of water into built environment has got many adverse impacts. First of all, it will affect the health and safety of the occupants. Secondly, it can create short circuits and thereby fire, affecting the fireworthiness of the building. And any entry of moisture or water into the structure certainly will create deterioration, thus affecting the structural durability. And finally, the aesthetics. You can imagine if the water leakage outside or if there is a watermark outside, how bad it will be and how it will affect the aesthetics. So waterproofing is an essential element, and it is vital to make sure that your habitable area is healthy and safe, and the structure remains sound, and your architectural aesthetics is maintained throughout the life period or the service life of the building. And there are many avenues for the water to enter into the concrete. And you all know water is a material that looks for avenues to enter. And concrete offers a large number of avenues for the water to enter. It can permeate through capillary pores in the concrete. It can enter through cracks in the concrete. It can enter through joints and discontinuities in the concrete. It can enter through insertions, which we normally make in any concrete construction. And finally, it can enter through defects. And Indian construction industry is famous for defects. Could be honeycombs, could be surface defects, it could be voids, it can be anything. So there are many ways for the water to enter into the concrete. First of all, is the pores. Let us see one by one which are the avenues. So when the cement hydrates, two types of pores will be created. One is gel pores, which is very small in size and will not create any water ingress or permeability. But the capillary pores, which are much higher in size, will certainly allow the water to enter. And this capillary pores makes the concrete permeable. And when the capillary pores are interconnected, they act as a conduit for the water and the deleterious material to enter into the concrete. The relation between porosity and permeability of concrete, we all know, but starting point, let me explain it. As we all know, the porosity increases, the permeability increases, but it is not a straight relation. Its relation is a very interesting relation. You can see the horizontal side, the capillary porosity, that is in percentage, that is the voids as a percentage of the concrete volume. That is the capillary porosity. Then the coefficient of permeability, it is nothing but the velocity or the speed at which water can enter the medium. So this relationship is somewhat like this. So beyond a certain stage, the permeability increases drastically. It increases asymptotically. Say around 20% of the porosity, the concrete is practically impermeable. You can consider concrete as impermeable. But beyond 20%, once the porosity increases, the permeability drastically increases, and around 35%, the concrete is practically a porous material. Now, cracks in concrete. We all know why concrete cracks. Concrete cracks, it is an inherent nature of the concrete. We cannot avoid it, but we can certainly control it. It's an inherent property of the concrete to crack. And it cracks at all stages of its existence. It could be in plastic stage, it could be in hardening stage, it could be in hardened stage. So why it cracks at the hardened stage? Because we know concrete is a brittle material, and the tensile strength of the concrete is very low compared to its compressive strength. We all know that one. So whenever the tensile stress develops into the concrete, and whenever it goes beyond the current tensile strength of concrete, it cracks. This is why the concrete cracks, and it's an inherent nature of the concrete to crack. Now, cracks in concrete can be many types, but basically we can categorize into structural cracks and non-structural cracks. Structural crack can be dealt at the design stage itself. It could be done by proper detailing or proper design factors, or it can be taken into account by various methods. The designer can take care of it. But the non-structural cracks at the design stage, it cannot be taken care of. It has to be taken care of at the construction stage. And there are many non-structural cracks happens in the concrete. There could be plastic shrinkage cracks that happens at the plastic stage. You can see the photograph. These are the typical plastic shrinkage cracks. This is mainly at the surface. And this is due to the volume change due to evaporation of water from the surface. This type of cracks normally do not permit water leakage or water permeation, but at a subsequent date, as the time goes on, this cracks can widen or this can enlarge due to weathering and subsequent loads. The next category is the drying shrinkage cracks, and of course then thermal cracks. And the drying shrinkage cracks, you can see a typical drying shrinkage crack here is a through and through crack. It will certainly allow the water to enter into the structure. And then thermal cracks. Thermal cracks is due to the variation in the temperature of the surrounding temperature, the atmospheric temperature. And if the structure is allowed to move without any restraint, there is no crack. But all the structures, we know some restraint or other will be there always. So whenever the temperature goes down, it mainly happens when the temperature goes down, not when the temperature goes up, or when there is a temperature differential within the section, tensile stresses will be developed. And this tensile stress will be proportional to the restraint strain. How much strain is restrained? It is proportional to the restraint strain. And again, here also, whenever the induced tensile stress goes beyond the tensile strength of concrete, it cracks. Now, what is the effect of concrete cracking? Cracks will certainly permit the water ingress. And if the crack is continuous, the ingress will be faster. Cyclic loading and weathering make the discontinuous cracks continuous. So over the time, be it weathering, whether it is loading or whether it is fatigue, the crack will only widen once it develops. So crack must be controlled or minimized to reduce the water ingress into the structure. Now, there are many joints. There will be many joints in the concrete. No major concrete can be done without joints. We know why we give the joints. Joints are given for different purposes. There are many purposes for which joints are given. First of all, we have got contraction joints. This is to take care of the contraction while setting and hardening. Then we have got construction joints. No concrete can be done continuously. Major concrete can be done continuously. Somewhere or other, we have to stop. When we restart after its final setting time, a cold joint will be developed. That is a construction joint. Then, of course, there will be expansion joints. No complex, no major structure can be done without joints. And these joints are required not only for thermal expansion, but also to take care of the seismic behavior of the structure. So all the joints in a structure has to be treated to prevent the ingress of water into the built environment. Now we do a lot of insertions in the concrete. No major concrete is done without insertion. There could be pipes. You can see the pipe inserted here. There could be sleeves inserted into the concrete, and you can see a hole here. And it's a very interesting thing. A hole is made in the raft, and the raft is against the water thrust. The water table is very high. And you can just imagine whatever the treatment you give below the raft, if this cutout is not treated, it is going to leak somewhere or the other. That is the criticality of this type of insertions and cutouts. Now we put anchors into the concrete. We put ducts into the concrete. You see it's a tie rod hole. This is basically provided for retaining the shutter at the concreting stage. This all creates subsequent leakages if not properly treated. And construction defects. Indian construction industry is famous for defects. And you can see the photograph. This type of defects is not a defect as per our industry norms, because whenever the de-shuttering is done, the labor comes and plasters it over, so that nobody will see it. So what they are doing is not treating the defects. They are only camouflaging the defect, which subsequently create a lot of leakage and dampness problem. Here in this photograph, you can see a lot of defects. It could be honeycombs, it could be surface defect, it could be voids, it could be even, you can see, these are the tie rod holes. If it is not treated, you can just imagine what will be the implications. And the most important thing you have to note in this photograph is there is a fabric here. This fabric is provided at the junction of the next lift, that is at the construction joint, in the shuttering to provide the slurry leakage. But unfortunately, instead of preventing slurry leakage, it has gone into the joint. You can see it is partly going into the joint, making the situation more worse. I mean, it is making it easy for the water to enter. So such construction defects has to be identified and treated properly if you want to have a successful treatment. Now, let us see what are the reasons for failure of waterproofing treatments. With all the care we do, still it fails. What are the reasons? What could be the reasons? First of all, selection of an appropriate system is essential. If you select an inappropriate waterproofing system, it is bound to fail. There are many waterproofing systems. There is no panacea for all the waterproofing situation. You have to select an appropriate system for a particular situation. Then incorrect installation. So even if you are selecting an appropriate system, if it is installed properly, or if it is installed by incompetent or inexperienced people, again, chances are there it will again fail. Then inadequate detail is very important. If you treat 99%, is no waterproofing. Waterproofing has to be 100% waterproofing, then only you can have an effective waterproofing. So let us come to what are the essential requirements to make your waterproofing successful or effective. I will go one by one. First of all, ensure high performance of the concrete against water ingress. Make sure that your concrete is high performance against water ingress. Then select an appropriate waterproofing system. It's very important. A wrong system will lead you to a lot of problems and headache at a subsequent date. Then give importance to detailing. You identify all the vulnerable points. If you spread the sheet or if you put a coating and that you feel that that is enough for waterproofing, it's not enough. You have to do 100%. The balance 1% has to be identified. All these vulnerable points are to be identified, detailed out, and treated separately if you want a 100% leak-proof situation. Then, of course, your applicator should be competent and experienced. An incompetent applicator can spoil the whole thing. And finally, test the completed waterproofing, which we never do. We only test the components or a part of it. We never test it after installation as a completed waterproofing. This is also very important. These are the factors we have to consider to make your waterproofing good. I will elaborate some of this situation to make it more clear. First of all, let me explain the importance of selecting an appropriate waterproofing system. This is one of the crucial aspects in the success of a waterproofing of the building. This is done with a case study. This is a building which you all must be knowing. This is it's a new complex building of the Supreme Court of India. This is a layout. You can see the existing Supreme Court building by its shape. You can easily identify. The metro station is on the left side, and the Madura Road is on the left side of the existing building. And across the Madura Road is the new complex, which is recently there, but few years it was constructed as an expansion to the existing Supreme Court complex. I'll explain the need for selecting an appropriate waterproofing system with the system we adopted for this particular project. So this is a huge complex. It has got 3 basements covering the entire buildable area, and it is very near to River Yamuna, and the water table is very high. The raft level is around 15 meters below ground level. Water table is about 2.5 meters ground level. And you can imagine the building is subjected to an upward thrust of 12.5 meters of water head throughout its life period. So we had to be careful in planning and in executing the waterproofing treatment of such a structure. And moreover, you can understand what is the implication of failure here. This is the details. The basement is here. This basement covers the entire buildable area, which is permitted for the plot. And over that, different blocks, different towers are existing. Wherever towers are not existing, they are used as a podium, maybe for parking or for garden and all this. So water table is practically to the ground, say around 2 or 2.5 meters below the ground level. So this basement has to be treated effectively so that subsequently there should not be any major headache or problems. And this basement, in addition to parking, mainly it is parking, it has got all vital installations of the structure, be it electrical installations, be it firefighting installations, be it air conditioning plants, all require an absolutely dry surface for its proper upkeep and maintenance. And problem is complicated by the presence of soil anchors. You know, there is an uplift of 12.5 meter head of water throughout the life of the structure. And the building has to be hold down against buoyancy. And soil anchors are provided to hold down the structure against buoyancy, against the uplift forces. So we have provided soil anchors of a different capacity. The spacing was provided differently. At the tower area, the spacing was less. Non-tower area, it is very close because the uplift will be effective uplift will be more in the non-tower area. And the things you have to note here is these soil anchors will pass through the raft. That means it punctures through the raft. And these are priestess and is anchored at the top of the raft. You can see the soil anchor here. And again, the soil anchor is being priestess and anchored at the top of the raft. This is the details of the soil anchor. The layout you can see, the black one you can see the structural columns and beams. And these are the grids. You can see these are the priestess soil anchors provided in regular grid below the raft. And if you see the section, it will be more clear. The raft is here and the soil anchors will puncture through the raft and is anchored to the top of the raft. You can see the photograph of the soil anchors before the raft is cast at the excavated level. You can see it is being installed. These anchors are being installed before casting the raft after excavating to the required levels. And whatever you see the protruding one, these are the soil anchors installed. So what we initially considered, what was initially considered this waterproofing system is the typical Kota stone system. This is a traditional system we adopt mainly in Delhi and surrounding areas. And it has withstood the test of time, and most of the cases it worked well. And I am not finding any fault with this system. Many important buildings were provided with this Kota system. And as a second layer of defense, crystalline waterproofing treatment was given the raft, so that there's something to resist even if the Kota stone fails. This is the initially considered waterproofing system for the project. But we made an analysis whether it will work, whether it can create any problems. So first of all, we observed that Kota stone is a rigid system. Like any stone is rigid. There is a very possibility that the stone will crack or the joints will crack while stressing the soil anchors. So every possibility is that it's cracked. And once the Kota stone is cracked or the joint is cracked, again, this treatment is of no use. Secondly, it's a vast area of the raft. The raft itself covers more than 8 acres of land. And there could be possibly local settlement of soil below the raft. It's a vast area. Now, if the Kota stone is provided and if a local settlement happens, Kota stone will detach or separate from the bottom of the raft. Again, allowing the water to enter. It can travel vertically through the raft or it can travel horizontally between the raft and the stone, leading to leakage somewhere else. And at a subsequent date, it is very difficult to know what is the source of the leakage. And finally, the soil anchor and the raft interface will be extremely difficult to waterproof with the Kota stone. We cannot make a foolproof waterproofing treatment of the interface of soil anchor and the raft. So we evaluated what are the requirements for a successful water system here. First of all, the material should be flexible. It should not crack under the pre-stressing load of soil anchors, the prime criteria. Secondly, it should not separate from the structural concrete in the event of a local settlement of the soil. It should stick to the raft. Thirdly, in the event of damage or puncture of the material, any layer, any sheet can damage or puncture while laying it. So in the event of damage or puncture, the water should not travel laterally between the concrete and the waterproofing layer. They should not allow the movement of water with the interface of concrete and the sheet. And finally, the waterproofing treatment at the interface of soil anchor and raft should be foolproof. We should get a foolproof system of waterproofing the interface of the anchorage. So after evaluation, we evaluated many waterproofing systems. Finally, we decided to replace Kota stone system with SDP fully bonded membrane below the raft and self-adhesive bitumen sheet on the external face of the retaining wall. You can see here SDP sheet is provided below the raft and bitumen sheet is provided in the vertical side of the. And as a second layer of defense, we retain the integral crystalline waterproofing treatment in the concrete of the raft. This is what we are finally adopted. These are details here. SDP fully bonded sheet. This can be easily creased or bent 90 degrees without damage to the vertical face, so that there is a discontinuity at the corner. And on the vertical face, we are given with a thin sheet which properly overlap at the vertical face of the raft. This it has got an interesting behavior, SDP sheet. It has got a pressure sensitive adhesive which bonds integrally with the concrete poured over it. That was a great advantage for us. Once it is bonded, lateral movement of water can be certainly avoided. Then it has got other major technical parameters provided by the manufacturers. Initially, we are also apprehensive whether a green concrete placed over sheet, whether it will really bond with the sheet. No testing parameters were available at that time, maybe a few years back. So we, as our own interest, made a cube over the sheet. And after curing and hardening, we tried to detach the sheet. And certainly with the manual labor, at least manually, it was not possible to detach it, showing that there is enough bonding between the concrete and the sheet, so that the horizontal transmission of the water could be avoided. The laying was also comparatively easy. It is laid over the leveling course, that is lean concrete. It has the sheets are laid with an overlap of 75 mm. And after laying, a plastic release liner is removed and the reinforcement is placed over that one. You can see overlap of the sheets. And here main advantage was that there is no heating, no torching, no welding. It is only simply laying and sealing the joints. You can see the photograph, how it is laid. This gives all the details of the sheet system, the soil anchor. This is the casing pipe that passed through the thickness of the raft. And this white one is the SDP sheet. And this longitudinal joint, they call it selvage overlap. It's a very easy overlap. You remove the protective layer, and just press it with a roller, and your joint is ready. And you can see how it is made, this overlap. So just by pressing a roller, this joint is ready. But the cross joint is a non-selvage joint. We had to provide an additional tape to get a proper joint. You can see here, an additional tape is provided at this point. Now you can see the photograph. You can see here the casing pipe within the thickness of the raft, then the soil anchor. And this interface has to be properly treated. Otherwise, there could be every possibility of water entering into the built environment through this interface. So what we have done is very interesting, how the detailing was worked out and how the detailing was properly treated. This is what I'm going to explain here. You can see here the sheet. The white one is the sheet waterproofing layer SDP sheet, and the black one is the pipe, casing pipe. And wherever the casing pipe passed through the sheet, there is a profile cut. The sheet is profile cut at this joint. So this sheet is laid and is extended on the vertical surface also without any discontinuity at the corner. Similarly, at the vertical face of the retaining wall, you can see the vertical face of the retaining wall. And here the bitumen sheet is provided, which is also again self-adhesive. Now, we have seen what is the importance of selecting appropriate system. Now let us see the importance of detailing, how the detailing has to be worked out to make sure that your waterproofing really 100% sure that it will not fail. So the detailing also will be, I will elaborate or explain with the friends the same project of the new complex of the Supreme Court at Pragati Maidan. And this is a section showing the details of the soil anchor. You can see the soil here, the PCC, then the raft, and top of the raft. And the casing pipe is embedded in the concrete, and the anchors are here, and it is anchored to the top of the raft. This is a system of the anchor, soil anchors. Now, there is many possibility that water enters through this interface. You can see the photograph here. It is being pre-stressed before anchoring to the top of the raft. And after pre-stressing, the cement grout is provided within the space of the casing pipe. Now, what are the probable water entries? Before detailing out, we have to see what are the probable water entries in this interface. First of all, water can enter through the grout, cement grout. Secondly, water can enter through this joint where the casing pipe and the waterproofing sheet meets. This joint is a very vulnerable joint where water can easily enter. And thirdly, finally, it can enter through the interface of concrete and the casing pipes. So all these points has to be detailed out and how best to prevent the water movement within the raft. So areas to be treated are the grout, areas to be treated are the corners, and areas to be treated are the interface of the pipes. This has to be detailed and treated. Now let us see how to take care of the grout. So what we have done is we provide a crystalline modified grout which prevents any water entry through the grout. That's the first blockage. Secondly, the joint. You can see the casing pipe here. You see the layout. The casing pipes are here. And there is a joint. There is a profile cut at the junction where the casing pipe meets the sheet. So this junction has to be treated. So first of all, we have wrapped a tape around this one. You can see this one. This is wrapped. This is not tape what we are seeing. It is a protective cover. Once the protective cover is removed, you can see the tape here. And this tape is also self-adhesive. That this concrete can stick to this tape. And then the joint between the tape and the sheet is treated using a liquid applied membrane. We seal that joint. That means there is absolutely no chance for the water enter into that one. So that completes the detailing of the joint and the you can see the detail here, casing pipe, the tape wrapped around the pipe, and the liquid membrane. So 3 layers of treatment is provided to make sure that this won't leak. You can see in the overall view of these junctions. You can see here, each of the junctions are identified, detailed out, and treated. Now, third one is interface. Interface also water can enter. There's a possibility. So what you have done is a hydrosoluble water stopper is provided at the midpoint of this one, so that water will not go beyond this level at any case. Now, many construction joints are there, numerous construction joints are there, and in the raft and the retaining wall, and all these construction joint has to be identified and treated. Otherwise, there's no guarantee that your waterproofing will be effective. The vast area of the raft, there will be hundreds of construction joints in the raft. Similarly, there will be numerous construction joints in the retaining wall, which all are vulnerable points for the water to enter. So what you have done is at the construction joint, you can see here casting 1. And after some days, we do the casting 2. So before casting 2 is done, we insert a hydrosoluble water stopper and then do the casting 2. So even if the water by chance enters through this joint, it will be stopped at the hydrosoluble water point locations. So similarly, in the retaining wall, at the middle of the joint, hydrosoluble water stop is provided. This hydrosoluble water stop behaves somewhat like this way. This soluble water stop expands when it comes to contact with the water. In the dry condition, it may not swell. So when it swells, expansive forces will be formed against the concrete faces. And this expansive forces makes a seal against hydrostatic pressure, stopping further water movement. It's a very plastic, it's a malleable material, and easy to put over any surface of concrete. It comes in strips. You can see the photograph here. Only concrete has to be thoroughly cleaned and remove of all the spatter and nibs. And you put a primer there, place the material and press with your thumb to firmly put in place. That's all the cut to place in this one. You can see one of the construction joints, this material, this hydrosoluble bar is placed. Then pipe insertion, as I told, all major construction. There will be a lot of insertions. A typical pipe insertion is shown here in a RCC retaining wall. Can see the RC wall, this outside, where the treatments are given, preformed membranes are given. Wherever the pipe inverts, there is a puncture or there is a discontinuity in the sheet. So what we have done is in such point, again, liquid applied membranes are provided to seal the joint. And as an additional precaution, hydrosoluble water stops are provided at the middle of the. You can see a photograph. The blue one is the hydrosoluble water bars in the construction joint and also around the pipe. Then tie bar holes. See how the detailings are required here. See, to keep the shuttering on both faces of the retaining wall, we have to tie together the shuttering on both sides. And tie rods are used mainly for keeping together the shuttering. You can see the tie bar here. And after removing the shuttering, you get a hole in the concrete where the tie bars are provided. And one can imagine if this hole is not treated properly, what could be the implications. So what we have done is these holes are filled with the crystalline modified mortar. And in addition, as a precautionary measure, 2 quarts of crystalline modified slurries are provided both at the inside and the outside to make sure that absolutely there is no chance for the water to enter. So next factor you have to complete is your experience of the applicator. The applicator should be experienced in the particular system of application. If the system differs again, it could be of no use. So you have to thoroughly evaluate the competency and experience of the applicator, especially for major works for carrying out the waterproofing works. First of all, you should ask for similar works and experience with the similar technology executed by the applicator. We can always get feedback from the clients who execute the similar works. And we can certainly verify the training undergone and certification earned by the applicator. And one of the important parameters is that please check the track record regarding fulfillment of waterproofing contracts, performance guarantee claims, especially his performance in the rectification of the defects subsequently. Then another important thing is all the work of waterproofing should be supervised by an experienced and qualified engineer or supervisor. Most of the waterproofing subcontractors, they send their labor and do the work, which should not be permitted. There should be a constant and continuous supervision by qualified supervisor. We have to make sure that it's supervised. The next aspect, testing after completion. This thing which normally very few projects do it because it is very cumbersome to do the testing after completion. We require a lot of water. It has to be retained for a few days. And after retaining, the water has to be thrown out. Because of the difficulty of really doing the water testing, most of us do not carry out the testing of the completed waterproof system in all respects. So, but nowadays we have got the different easy tests are available, like integrated testing, moisture detection testings are all available, which is not that cumbersome as flooding the area and checking this one. And this testing of the completed waterproofing system is we have in detail explained in the handbook on waterproofing published by the ICI. So let us summarize it. Water enters through capillary pores, cracks, joints, insertions, construction defects, and all this. So first and foremost thing is, at every stage of concreting process, you make sure that there is proper care so that the concrete is a high performance concrete against water ingress. Make sure that one the first and foremost requirement. Then select an appropriate waterproofing system. It is very essential. The wrong system can lead into a lot of problems. Then select an experienced and competent applicator. Spend some time, evaluate him, then only engage him. Then proper detailing at junctions, joints, and insertions. Very important. Spreading a sheet or putting a coating on 99% of the area, which is more easy and more payment-wise, it covers the most of the payment. That is not sufficient for an effective waterproofing. The remaining 1%, the vulnerable points has to be identified, treated separately to make sure that water will not enter through that. Then finally, test the thing after installations. So let me come to the second part of the presentation. I will also cover some of the waterproofing technologies available so that you can make an informed choice while selecting the system for your particular requirement. I'll give an overview of the present day or the state-of-the-art waterproofing technologies available. See, conventionally, we all know we go for conventional system like Kota stone or brick cobas, lime terracing, bitumen application. Bitumen application is quite common. But with the advancement of polymer technology, we have got a host of modern waterproofing systems. Some of them I will be explaining in the subsequent slides. So modern waterproofing systems are basically classified into 3 or 4 categories. You can see the list here. First is a integral waterproofing system. Integral means it become integral with the concrete. That is why it's called integral waterproofing system. Then we have coating and liquid applied membrane systems. Then we have the preformed membrane systems. That means sheets, STP or PVC sheets. Then we have got another system of waterproofing called impregnation system, which I will explain subsequently. Then, of course, we all know grouting systems. Grouting system is mainly used for the existing building, existing defect rectification in the existing building. But all the other 4 can be utilized either for a new application system or for an existing leakage rectification. Now, come to the integral waterproofing systems. I will explain. It is integral because it is integral with the concrete. They are added to the concrete during mixing. Different types of integral waterproofing compounds are available. There can be water repellent. There can be air entraining. There can be crystalline compounds. Many types of integral waterproofing compounds are available. Basically, what they do is they make the concrete impermeable. That means they fill up the gaps and micro cracks. This is what they do. Out of this integral, crystalline waterproofing is very popular. So what they do is these crystalline compounds, they form insoluble crystals in combination with water. And this crystal plug the pores and micro cracks of concrete. They remain dormant once the concrete has dried. And subsequently, if the water enters in the dried concrete, the active ingredients of the compound, they react with the free light, that means calcium hydroxide, and start forming insoluble crystals. You can see the photograph. The white one is the crystals, and this is a self-healing process. It is something unique to these crystalline waterproofing compounds. Then we have got coating systems. This is another useful method of waterproofing. There are many coating systems available. Many cementitious coatings, modified cementitious coatings, acrylic coatings, polyurethane coatings, polyurea coatings. A large number of coatings are available to treat the water leakages. So, before going to details, we should understand what are the essential main requirement of a good coating system. What are the things it should satisfy so that this coating system will be successful against water leakage. First of all, the material part. The material should possess an excellent bond with the substrate. That means it should bond with the concrete. It should not detach, it should not come out. And second, very important aspect is it should be breathable. Breathable means it should allow water vapor from inside to outside, not the other way. Breathable, you can just imagine, your skin can breathe. It can send out the water particles or sweat, but it cannot take the water inside. So it is something like this one. If the water vapors are accumulated within the concrete or within the interface between the concrete and the coating system, it will create bubbles. It will come out, it will detach, and once it is detached, it will be of no use. Secondly, at least it should crack micro cracks. It should not crack with the cracks. And it should elongate and recover when exposed to cyclic stresses. That means for fatigue or cyclic stresses, it should move and come back. And of course, it should be durable. It should stand as durable as the building. And environmental consideration should have a limited or no VOC. Then for the successful treatment of the coating system, the surface preparation is very important. The substrate should be prepared absolutely up to the requirement. Then only it will be successful. Then method of application should also be correct. Otherwise, every possibility is that the coating system can fail. You can see some of the coating systems here, photographs, just for information, different types of coatings. Then next one is liquid applied membrane system. Here the difference between the coating and the liquid applied membrane is mainly in the thickness. Liquid applied membrane system is much more thick. So it can be applied by brush or by spraying or spreading, but usually it is done by spreading. What it does is it forms an elastomeric membrane. And this membrane can stretch and return to its original shape without damage. And because it has got thickness, it can be reinforced. And it is very easy, especially for complex geometries. It is application easy because it can flow into different complex geometries. And it forms a flexible membrane, seamless membrane. That means there is no joint anywhere that fully adhered to the substrate. You can see the typical application of the liquid membrane by spreading. Deck waterproofing of a bridge using liquid membrane. Now the other major system is preformed membranes. We are all aware of these preformed membranes of different categories. We know conventionally, age-old, bitumens were used as membranes. We are all familiar with the bitumen membranes, but bitumen has got a problem. It has got a great waterproofing property, but its mechanical property is depending on the temperature. All its physical properties changes with the temperature. Say it becomes brittle at sub-zero temperature. It turns viscous at the elevated temperature. And at the moderate temperature, it is viscoelastic solids. So it is a material where its tensile strength, breaking strain, elasticity, all changes widely through normal cycle of temperature. So this limitation gave rise to modern membrane systems. And we have got Hessian reinforced tar felt. Almost 50 years back, it was in the market, and it was very widely used for waterproofing treatments. In fact, over a period, tar felt became a generic name for all the felts. All the felts we used to call tar felt. Then EPDM and neoprene membranes came in early 80s. Then APP and SBS membranes were introduced in early 90s. They were available with the different reinforcements, maybe polyester, glass, or STP. And this reinforcement increased the tensile strength, puncture resistance, and elongation capabilities along with fire resistance. So a wide variety of membranes are available. You can see a deck waterproofing using APP membrane here. It's a deck of the signature builds where we completely use APP membrane to waterproof the deck. Now, with the advancement in polymer technology, the bitumen has relegated to the backside, and many new membranes become popular. Mainly the PVC, polyvinyl chloride, then high density polyethylene, SDP, then thermoplastic olefin or TPO. These all are the modern membranes available now. PVC membranes are available in different forms. It could be UV resistance or non-UV resistance, fire resistance or non-fire resistance, reinforced, non-reinforced, all available in the market. Similarly, we have got STP membranes are available. Two forms are very popular. The one I explained, cell adhesive membrane, we can stick to the concrete poured over it. And there is a mechanically bonding type. Both are being extensively used. Then we have got TPO membranes, which combines the properties of EPDM and PVC. Then the next system is impregnation system. This is different from coating. Coating works by adhesion. That means it sticks to the surface. Whereas the impregnation diffuses into the structure. It will become integral part of the structure. So here the effect is basically because of the physical diffusion of the chemical and the chemical reaction. So the penetrative and the reactive chemical is applied on a cementitious substrate. It diffuses into concrete and block the pores and micropores. The proven technologies as on today are organosilane technology and crystalline technology. Organosilane technology is a very commonly used method. It is water dilutable, easy to apply, and long service life. And another advantage is eco-friendly. This molecular size is very small. It can even penetrate the micro cracks and nanocapillaries. Only thing is that it has to be applied fresh on the concrete surface without giving any coat, because once you give the coat, it cannot diffuse into the concrete. Crystalline imbrication is also very important. We have seen how the crystalline technology is used as a material added to the concrete. Here, it can be used as an imbrication technology also. Crystalline chemicals, it use water as a medium to migrate into the concrete. Once inside the concrete, they react with the lime, calcium hydroxide, resulting in soluble, non-soluble crystalline structures, which I explained previously. These crystals will fill up pores and micro cracks. It can be applied to the existing concrete surface over a fresh concrete as a dry shake application. Are you telling something? I will take 2 more minutes. It can be applied by brush application or by spray applications or by dry shake application over the green or partially setting concrete. Then grouting systems, as I told you, this is mainly used for the existing structures where there are cracks, honeycombs, porosity, voids, cavities. It's all situation we resort to grouting systems. Make sure that the grout is flowable. It should be non-shrink and remain stable without cracking or crumbling. And popular grouting systems are cementitious grouting, as we all know. Then polyester polymer grouting system. Popular ones are epoxy and polyurethane grouts. The cementitious grout is still the most popular one because it is readily available, cheapest, and compatible with many surface and substrate conditions. But it can be resorted only when the cracks are dormant. If the cracks are expanding or widening, it's of no use, and especially useful for large voids and honeycombing. And this grout circuit admixtures to impart non-shrinkable properties and improving the flowability. Then we have got ultra fine grouts, which can be used for micro cracks and gaps, which cannot be usually grouted by the cement grout. Then epoxy grouts are very popular. Again, they are non-shrink, flowable. They have got excellent bonding, with almost all the material, good chemical resistance, and effective in sealing micro cracks. But again, if the cracks are stable, then only it will be effective. Negative points are low port life, non-resistant to ultraviolet exposure, and high temperature. It is not good for high temperatures. And of course, it is not an environmental friendly material. Then polyurethane grouts are also getting popular. Its main advantage is that its low viscosity allows it to penetrate into micro cracks. Environmentally inert, but the costs are high. Then if the grouting is not possible, or the concrete is so weak, grouting will not be successful, they can think about curtain grouting also. When the injection grouting is not possible in a concrete, we can certainly for curtain grouting, what we do is you grout beyond the concrete. That means you grout into the soil to make a curtain. That's also another possibility of grouting. So these all are the present day technologies available for leakage treatment and rectifications. So I will take a few more minutes to give a brief of the handbook published by the Indian Concrete Institute so that you are aware of such facilities available. It's a first of its kind. It's the first comprehensive handbook on waterproofing in the country. It is prepared by a technical committee constituted by the Indian Concrete Institute. It is published in 2021. It is authored by eminent personalities in the field of waterproofing, which includes manufacturers, applicators, consultants, specifiers, clients, builders, researchers, environmental experts, and safety experts. A wide spectrum of people has contributed to making of this book. And these are the authors for this handbook. Now let us see the coverage. What are the coverage of this handbook? I'll just glance through this one. It starts with the principles and mechanism of waterproofing, followed by enhancing the performance of concrete against ingress of water. It elaborates various types of waterproofing technologies, materials, application methodologies, with plus points and minus points. First of all, it covers the coatings, different types of coating. Then It covers the liquid applied membrane systems. It covers the preformed membrane systems in detail. It covers the grouting systems in detail. It covers the impregnation systems of waterproofing. Dedicated chapters are given to all these types of waterproofing technologies. Joint treatments are given a lot of importance. And a full chapter is given for detailing. A lot of useful sketches were provided for normal construction requirements. Then integrated testing is one of the major gray area in the construction industry. As I told you, we do not test a completed waterproofing system. This book's an exclusive chapter is given how to do integrated testing of installed waterproofing systems. The very important chapter content, how to select an appropriate waterproofing system. It gives guidelines. We have got a plethora of systems, materials, and application methodologies. People get confused. So this chapter gives a guidance how to select an appropriate system for your waterproofing system. Your success depends on how to match the performance parameters, your product or the system with the behavior pattern of your structure. There lies the success. Here we gives a lot of guidelines how to select it. Then waterproofing of tunnels is covered. To make it comprehensive, we have given model contract specification and SOPs. We have also included codes, related codes, standards, and references. Health and safety along with green features are also covered. So all these contents, all these coverages are covered in 18 chapters. All the aspects related to the waterproofing is covered in 18 chapters. Now, this is available. The pricing is at 1,500 plus rupees, 50 as postage, and there is a bulk discount. If you purchase 5 or more copies, 20% discount. If you purchase 20 or more copies, 30% discounts. And it's purchasing easy. You can make the payment through the website of the Indian Concrete Institute, or directly you can make through the bank details of this one, or you can even get in touch with the Secretary General to get a copy of this book. So with this one, I close my presentation. Thanks to all of you. Thank you. Thank you very much.
Vikas, any questions?
Hello. Yes.
Any questions?
Yes, sir. There are some questions in the question answer box. First one is the
Boliye, and then see he'll reply.
Yes. The Mr. Devendra Verma asked, will the crystalline compound get activated during curing by any chance?
That is what the manufacturer tell. It will not get affected initially, but after some time, when the concrete is dried, the water comes, it will get activated. Thank you.
Okay. The another question is, sir, are integral waterproofing admixtures allowed to be used without the use of an external membrane or coating?
Can you repeat?
Are integral waterproofing admixtures allowed to be used without the use of an external membrane or coating?
See, that is up to you. We can always use it, but it may not be effective because this integral membrane system certainly cannot take care of larger cracks. It can only fill up the pores and cavities, or pores, micro pores and other things, or micro cracks. It cannot handle the major cracks within the structure. So by using itself, only my integral part may not be very effective.
Yes, sir. Okay, sir. Thank you, sir. The another question is, sir, kindly share your suggestions for waterproofing systems for podium slabs, which are, which are large in length and subjected to constant moisture interface due to landscape loading.
Yeah, we have to probably go for a combination of systems. One is we can certainly try for a membrane system, which is stretchable, which can take the traffic load also. And in addition, as a second layer of defense, you can think about integral waterproofing systems, especially the crystalline technologies. That will be effective. You can even go for membranes also, preformed membranes also. Okay.
Okay, sir. Sir, the another question is kindly advise for waterproofing in basement for seepage of water protection.
Existing building means you have to go for grouting, because you cannot practically, it's not possible to escape it all around the building and do treatment. So existing building, probably the best solution is to go for an appropriate grouting. Okay.
Okay, sir. Sir, another question is what kind of waterproofing system is best suited for independent house, rooftops and washrooms for typical North Indian climate conditions?
See, toilet is not a major issue because there is not much of a temperature variation. You can have for the normal coatings or liquid membrane systems, that is sufficient. But in the roofing, the main problem is expansion and contraction. We can certainly should think about something which can elongate and come back with the temperature variations. Nowadays, reinforced liquid membrane systems are available, which is very effective, or preformed membranes are available, which can take care of the temperature movement without cracking or crumbling. Okay.
Okay, sir. The another question is, sir, can you please suggest what should be adopted for green roofs?
Green roofs, I think I already mentioned the podium. Whatever you do for podiums is equally good for green roof also. You can certainly go for probably a reinforced liquid membrane systems and a second layer of defense as the integral part. That means the crystalline part.
Thank you, sir. Sir, another question is how the Hope dimple sheet will be effective for the water seepage at vertical positions in basements?
Pardon? Can you repeat?
How the HDPE dimple sheet will be effective for the water seepage at vertical positions in basements?
Dimple sheet.
Yes, sir.
I am not very familiar with the dimple sheet, but certainly basically the success depends on how fast it can be attached to the vertical surface of the retaining wall. It should be properly bonded to the retaining wall. And I doubt whether the dimple sheet can be easily attached to the concrete surface. Dimple sheet is normally provided for drainage purpose, not for waterproofing purpose. Okay.
Okay, sir. Yes, sir. These are the questions only. Thank you, sir.
So friends, hello.
Yes, sir. Dhawan sir, boliye please.
Friends, Engineer K.P. Abraham, as I said, there is a vast experience and knowledge, and how clearly he said that waterproofing just 4% of the total project, and in such a specialized work, we cannot leave everything. So the proper material, proper sequence of doing, and the proper persons in the supervision, there is no shortcut. And he has given a beautiful example of 3 basements in the same building, where the problem of subsoil water is very near to Yamuna. So gentlemen, any job that we do, we need to know detailing, sequence, and the specifications, and the right job to be done at the right time. So, Engineer Abraham, we are grateful to you for sharing your knowledge and experience to the young engineers. And I'm sure this information will be really fruitful. And if you can just give this presentation to Vikas, he can distribute to the listeners. So thank you, the listeners, participants. And then this is
just for Vikas.
Monthly event that we continue to do. So next month, next speaker, next topic.
Just 1 minute, Dhawan sir. Mr.
Vikas,
you can circulate the link of the recordings. It is recorded.
Oh, yes.
Yes, sir.
Right,
Sure.
okay.
And
Okay.
please give me a copy to me also.
Okay.
Right. Okay. That will do. Thank you once again. And then, so we conclude and then meet the next month. New speaker, new topic. And let's close and then bye-bye.
Okay, sir. Thank you.
Okay, thank you very much.